All right, let's get our hands dirty and we'll let's dive into the Flora system. Um, all right, so let's start with like a basic setup first. All right, so the first thing you do is you drop down the solver node, and the parameters are really large here. Um, so this is like the foundational element in the Flora system, or node in the Flora system. And Flora works a bit differently from your typical Houdini node tree, because typically you have like a node tree and you start off with like something and you add a transform and you sort of like pass the flow of data from top to bottom. Flora is a bit different. Flora does all the calculation thing and all the magic happens in the solver node. This is not just like a DOP solver or something like this. This is like a custom built solver based on for loops. And the flow of information goes from from bottom to top, but also from top to bottom. Like it's almost like a real tree where you have like the flow of nutrients and water. Like nutrients go up with the water, but also down and yeah. But predominantly the flow goes up, like just in the tree, with some feedback, like to be passed down, possible. So, and you start off by adding a component. This is like the base, like this is the foundation block, but these are the basic building blocks in the Flora system. There is a switch node, which is, I won't get into this for now. I almost never used it for what I did, because this is like a more advanced topic for Flora, and that would like go beyond it would just go beyond scope for now. So let's get back to this at a later point, maybe in February or something. We'll see about that. And if you now just hook this up, it will need a bit of time, because I have like 66 generations. This is like the global generations count I was talking about earlier. And it's like hooked to the frame. I mean, you can unhook it if you want, but it's kind of nice to like, you don't see 66 points, because this one is set to have maximum amount of generations of 8. Maybe let's increase it to 20 or something like this and see more going on. All right. Sometimes, I don't know why it's happening right now, but sometimes it's a bit buggy and you kind of have to like go back to 1 before it's taking effect, if you change like something with the generations. But here you can see sort of how the tree grows, and it's kind of neat. So I let it hooked up for now. But sometimes you don't want that, because you want to animate something with the frames, like the tree moving on a sort of, I don't know, whatever you want. Anyway, this is like now the trunk, and as you can see, there's like this like gradual decay of the branch length going on, and this is happening through the length. If I reduce this, then it will change the global length, because it just like decreases much more per segment. But I would just leave it on a default. The other thing is the like absolute setting, where every segment has the same length, and this is sort of the biologically correct setting. And I'll leave it at this for now. And now just like, let's add, okay, I think I'm going entirely off off script or off my list again, but bear with me, I think it's gonna be good. So yeah, I can just like direct this again. This one, I want to be like a lot shorter, like 8 is fine. And now we have our first branches. And they are, like, this is an alternating phyllotaxy by default. And you see it spiral around the trunk. And this spiraling is controlled by the twist parameter in, like, you have a global roll that rolls the whole component. And then you have the twist. And the twist, like if you turn it down completely, there's no twist at all, and every segment has like the same sort of thing. You could actually make something like feathers with this. Yeah, nature is fractal in itself. Like self-similarity is very common. Like the structure of the lung, blood vessels, and yeah, stuff like that. Anyway, you sometimes want to have like the default for the twist is the 137.5, and this is the golden angle. So it's like the golden spiral that like it's spiraling around in the golden spiral, which is like the underlying mathematical principle between this. But sometimes, like if you have an opposing pattern, or if you have like a leaf or something, or if you are making like a branch that's sort of horizontal and pretty flat, like a beach branch or something, you kind of want to keep this to 180. And there you go. You get like a flat thing, like for leaf veins or like also feathers and like branches that are sort of like flat. This is how it works out. It's not 100% biologically accurate, but it just is what it is. And yeah, now we get to the gotcha that I was talking about earlier. But here I want to have like 2 because of, or 3. Let's do 3. And let's save. Because you need to be really careful with this, because if I now add more branches to this component, you see how it is starting to be like a self-similar spiraling around itself with each like fractal step. And as fractals have it in them, they are really expensive to compute. And if you increase this for too long, you end up with like, I mean, let's do 3 for now and add more steps. Like it quickly gets really expensive and really like, yeah, you see what's going on. So be careful with this, but this is like really useful in making like shrubs and sort of very bifurcation like messy plants that have no like distinct shape through like large trunks or something like that. However, if you like, if we dial this back to 1 again, if we want to make like we have opposing now, but if we want to have like walled phyllotaxy, then we need to do something about this. And this is like we call this init for now, as this is the initially you know what I mean, the init step or the init component that I was talking about earlier. And we'll clamp it to 1 generation. And you can also, because we maybe want to bifurcate on top of here, like we want to make like the terminal split, and I want to do this with a separate component. So what I'm doing is I set it to spawn at end that it doesn't do that. So it's just doing lateral branches right now. And this is like the single axis pattern that we're working on right now. And yeah, we can set the length scale to like it is still, all right, it's still absolute. And if it's absolute, we can go beyond like 0.1. And like we don't need to right now, but we can, because if we would keep this to non-absolute, and if I now add the next component, then as you can see, nothing happens because I haven't set it to spawn at end. But now the next component is 2.6 times of what it was before. It will inherit, and the next component will inherit the length of the parent. And little rhyme right there, pun not intended. And yeah, you can like leave it at like 0.9 is fine. Another rhyme. You can leave it at that, and now you can add like more generation steps to this to extend it. Let's maybe dial down the 2.6 here a little so we don't get this ridiculous of a branch length. And yeah, now we want to have our walled phyllotaxy, and we do this in the init node, and we increase the number of branches here. And frankly, I'm still like a little bit confused about how this is working with like the cluster angle and all of that, because it's kind of weird how it does this. Now it is like this, and I kind of want to like change the component pitch, but if I change the pitch now here, it's not doing it. Like this is, yeah, this needs to be changed, but I don't know how. And I got explained like a lot of workarounds how to prevent this behavior because it's expected to work like this the way the code works, but I as an artist don't expect it to work like this, so don't worry about it. But all right, here we go. Like this sort of fixed it, I guess. Lucky. But yeah, I have no idea why. And now we have the opposing pattern or phyllotaxy pattern, and you kind of see where this is getting at. There's no like in SpeedTree you have like buttons. They are hard-coded sort of modes, phyllotaxy modes, but in nature you don't have this like strict division between phyllotaxy modes or types. It's more like a fluent gradient between them. And you could like use a control node to drive the amount of branches, or like to drive the way the walling works along the gradient, like of the length of the parent. But let's not get bogged down with this for now. I'll demonstrate it later on a simpler example, but yeah. If we do more than one branch here, like 3, then we get, like this is now getting walled. Like walled is anything from 3 to 7. I don't know how many, like I think 7 is like there aren't many more than 7, but watch your reference, or like mind your reference. And yeah, we have like a spacing here. There's an absolute setting here, which is like that the spacing is absolute and not like relative to the parent segment length. And if you have like a fir tree or something, or like a spruce tree, and you set it to 5, which is pretty common, or like let's do 6, then things get really weird. Yeah, prototype tools. Don't take this too seriously. This all will change eventually, but yeah, I have no idea how to yeah. It was really hard. I had a really hard time making content with this, but it was worth it nonetheless, and I'm really thankful for Feike who put this all together. Like without Feike, this wouldn't have happened. So thanks for that. Shout out to you, Feike Postmes. Google him. He's like a architecture wizard, and this includes like software architecture of tools about trees, while he never ever touched a tree in software in his life. So kudos for that. That's really amazing work there. Anyway, let's just leave it at that and be happy that we have this. You can, like, if you look at this almost looks like a needle cluster for like a pine or a fir or spruce. And yeah, maybe I'm getting a bit of ahead of maybe I'm getting a bit ahead of myself here, but let's just get some juicy stuff right here, because yeah, it's kind of nice to have to see some tropism stuff, and now it would be like even more than like a fur needle cluster, or like a fur twig with the needles. And right, I guess if you have like a needle thing, then you also end up with more than 6 or like more than 5. Like we can go a bit nuts here, and maybe we can get back to the 137.5 golden angle, so it spirals a bit more, and maybe we can disable the color for now. And yeah, then like this is a good segue for showing the control node. Because we kind of want to control the length of these things along the parent. And we do this by controlling the init node, actually. Because the init node is the segment which dictates the initial length, and the other one is just doing the fractional thing based from that initial length. So this is a bit like complicated to set up, or like a bit cumbersome. It's not complicated, but yeah, will be changed in the future probably. You have to register the control node in the Flora solver. The next step is that you have to register it in the component here. And now you can work with this. So what we want to do is we can now work with, like this is a bit cumbersome. I wish it would be like a bit more automatic in fetching like the data or like the frame of reference. But if we would like get a bounce and sort of figure out like what like height we have, so it's like about 10 meters, which is a really large fir twig. But now that we know that, we can set the height to 10, and what we want to drive is like the length scale. And if we look back at this, now we can see like, okay, this is working around the height. And if you wanted to control the length scale directly in this one, like if I disable this for now, register the control node here, and if we activate it here, then we override the current value. What you can also do is we can scale the existing one, which is just like a multiply operation. We can add min max, and you can sort of like stack these effects on top. Like I can say, okay, I want to override this so that I have like a length from 0 to 1. And now I can take the same thing, and we take the length scale again, and now I want to add like 1 to it, and now it just added like where it was 0, it's 1, and where it is 1, it is 2. And yeah, min, max, you get the point. All right. So what we can also do is we can like control the gravitropism with this, and now we have like the curve going on here, and we can get like really extreme, and we can sort of go into the negative as well here. Can we? It doesn't look. Oh, okay. Okay. Jesus. I broke something. Right. I know what I broke. Maybe let's remove this for now and go back to what we had. Gravitropism, and instead of going negative in this ramp here, because it's kind of fiddly to go negative with ramps, as you have to always sort of enter the value manually here, we just do the range. We define the range from 0 to 1. to 1, and now we have like negative gravitropism as well. And don't worry, we will talk about the tropisms in much more detail later. This is the control node essentially. I don't think I need to go into in any more detail with that. You can play around with this on your own. The only thing I might want to add is that instead of using like the hard-coded height here, because height is not always like the property you want to use, you can also use the what I like to do more, and something you can actually like hook up. If we take this here now and go into the maximum, no, if we take this one and take the like the maximum generations parameter, and we go in here and we just paste this as a reference, and we go into current generation, then even if I add more stuff here, like it will always be relative, like this curve in the control node will always be relative to the frame of reference of the parent. And this is what this should be like by default. Like if you drop down a control node, this should be the setting, and it should be linked to the respective maximum generation settings in the control node, in the component that this control node is registered to. But that's an easy fix to do, and I'm sure like Feike will do this a bit later. But yeah, this is the control node, and this concludes the control node. And now the initial thing that I wanted to talk about in the beginning before I went off script, and I think it was a good thing that I went off script. But the later things is like, how do I sort of switch with like the single axis and the gather axis stuff, like the bifurcation and lateral branches. How do I do bifurcation? Basically, that's left to talk about. And maybe I'm just like reading through my list and seeing there's one thing I can talk about for the control node as well. And this is the, but I want to talk about the spawn n out of n, which is the, like the frequency. Because right now I decided to keep the segment length here in absolute and don't have this decay integrated into the points, because I wanted to keep it a bit closer to nature. And now I can use the control node though to sort of add this this progressive sort of decay. And I hope I can add this. Yeah, it's kind of fiddly to control. Like the it's much easier to just leave it in with the default mode. However, what we can do like this is we can like get more control to how we spawn like smaller elements, because if these were now branches, like these curves, you might want to add like, or if we're looking at a twig, and this is like a twig that is branching off of the main axis, then you still have leaves spawning off of these nodes here, like these. And if you don't have them, then you can't spawn leaves. So you might want to keep like the main trunk with like non-absolute decay. And let's deactivate this. And now you get like this beautiful distribution. So you want to keep this for the main trunk like this, but if you're going into the like later stages, like the younger twig systems in the skeleton structure, you kind of want to keep it in absolute. So you have the nodes here to drive to spawn leaves off of. Yeah, because that was something that threw me off like completely, and where I didn't have the solution while I was making the assets. This just like dawned on me later how to do this, and yeah. Anyway, let's move on to the bifurcation thing. Now we have like let's turn down for what and go back to like 2, or maybe even 1, which now is a bit weird again, but here we go. Let's untick the simulation for now. So we get something easy to recognize and to work with. And yeah, now what we can do to sort of, like, there's a fluent gradient between bifurcation and lateral branching because everything is fluent in nature, everything's analog, there's no hard distinctions, and the trick or the art is for like vegetation system making is striking like a nice balance between the two. And I'm pretty sure like this is like the ultimate way of how this can be done. George has like extensive experience in making vegetation tools from like varying degrees of controls, like from no control at all and full simulation based on like environment properties up until like more like speed tree like systems with curve on curve scattering. And yeah, this is like a really nice sweet spot we're going into with the Flora tools. And what I mean with like the gradient between between bifurcation is that right now they are clearly distinct lateral branches. If we go back to the 180, it will get even a bit more. It will even get a bit more. Haha, got him. Or gotcha myself, because I tried to do the twist now, but this is just one element. There's nothing twisting in one element. The twist is always the thing that happens over multiple generation steps. And I'm not controlling the twist of the component by controlling its twist, which is a bit counterintuitive. I'm controlling the twist using the twist of the parent branch, which is, or the parent component, which is like this. And now that we have this, we can go back into the init component and we can, I think this one I could have used before to not get this confused. Yeah, the parameters are like kind of weirdly named. Like this is the branch angle, but this is the branch angle too. But also this is the cluster angle, and yeah, it's all a bit confusing. All right. You also have a bit of variance just to keep things interesting. But what I want to show is the kickback, which is, maybe this could be smarter solved. It probably can, because as I was talking, like the spiraling is also, it's not just light maximization or like light collection / exposure maximization. It's also structural integrity, and this isn't structural integer, or this has no structural integrity at all. Probably the plants do that by doing more spiraling. So if we go back to 175, no, this is something that has to be, maybe you can work around it with like using more init nodes at the bottom or something, or by using control nodes, but I wish there was like a more hands-on solution to this that sort of would figure it out, like would figure out how the weight distribution is in the tree. Like if we would measure the points, if we like put them all in a quadrant right now, then we see that there's like a disbalance in the like negative x and negative y, negative z, and then we could like direct the tool to sort of like spiral into a direction that's in another quadrant to sort of just auto figure out how to like spiral when presented with this kickback effect. But if we go really extreme with this, then it's we sort of get this zigzagging, almost looking like bifurcation motion into it. And yeah, this is like one way of sort of closing in onto bifurcation. And this is also something that you have in SpeedTree, because like in SpeedTree, it's in SpeedTree 9 now that they this purple curve here, SpeedTree would just spawn like one curve that has this length, while this is spawning like every step and figuring it out like step by step. And SpeedTree then has like a zigzag noise now that sort of fakes this, and then you can use the bifurcation mode in SpeedTree, which just figures out like strong angles. Yeah, SpeedTree then detects like the minima and maxima in the curve, like the change of incline, like you did in high school. And then it will spawn like a branch on like a new curve on these like maxima points, or like points of changing directions. And this is like a very how do I put it, basic approach of doing this, which is fine. It looks pretty good in many cases. But yeah, then we have a more sophisticated approach in simple tree tools. Maybe I can just like do it for comparison. Oops. SCT trunk maker. And here we have the inverted flow. Already we see we start with the trunk up here, while here we started with the trunk in the beginning. But if we now take like a trunk and we take a branch maker, then, and we, just for comparison, we also make the incremental roll, it's called here, but it's like the twist in the other one. And here we set the twist like in the branch maker, in the component itself, instead of the trunk, which is like much more intuitive. And but anyway, if we set it to 180 here as well, maybe we, and the same thing, like here we set the length between the nodes, we set it in the component itself. And this is like much more intuitive to work with. Like I really wish that Flora would take a look at this, or that George and Feike take a really careful look at how the system works. Maybe I can make like a video for them to showcase like everything, and that they would like sort of try and make a wrapping framework, like a wrapper around this core functionality that we already have in here, and make it a bit more like intuitively to work with, so that you could just set the twist in the actual component and it would figure out its parent node and set the twist like using Python or something in there, like internally. But yeah, that's none of your concern. This is for Feike and George, if you're watching. And yeah, here we have the same sort of mechanism, this sort of fake bifurcation thingy. And we kind of get the same problem though as we have in Flora. Like we get like an imbalance into one direction, which is kind of unlucky to work with. Like it makes it, I don't know how to use this, to be honest. And Niels, George, Feike, if you figure anything out for this, please let me know. Would be really cool. And yeah, but this just like as a small excursion into how like more conventional software works. Like this is more akin to SpeedTree. It's not a copy of SpeedTree. It's much more powerful than SpeedTree in many regards, but like not as convenient to use, because SpeedTree has all these nice like interactive features, and you have the photogrammetry trunk extension auto thingy and stuff like this. Like this sort of stuff isn't in here, but for instance, sorry for the tangent here. You can skip like 2 minutes if you don't care about this. But if you do, one of the core features of SpeedTree, and something that isn't quite in Flora just yet. I also won't go into the meshing of Flora, because this is sort of a messy area that I don't want to get like bogged down into. But this is the meshing in simple tree tools, and if we like go away with the bifurcation and make it a bit more like this, then we can now go into the seams system, and we can get seams, as it seems. And yeah, this is this is sort of the way how Speed3 does it. If we go away with the color, like you have really nice normal blending, and these are like detached geometries. They just like it ray traces onto it and has like a really nice fall off. But George did like some, like you kind of see like a seam of the texture, like the blending between the UVs here and here. It's not perfect. Please, Niels, you did a really great job in this, but George kind of one-upped you there and made some crazy UV space projection stuff and converting between 3D and 2D and back and forth, and just like attaching the UVs here, like pretty much that there's like a fluent transition. That's dark magic, and I yeah, it's fine that you don't have that yet. Maybe for the future. Anyway, let's not get hung up and get out of this tangent. Yeah, but that's for the better, because right now I have now my lateral branches, my single axis pattern, and I can activate this again. What I want to do now is I want to sort of start with the trunk feathering into a bit more like splitty behavior. Like let's imagine this is a birch, and birches like to have like a very straight trunk, but like if they are in forests, because they focus so much on primary growth. But I want to make them split now, because when a birch realizes, hey, I don't have a lot of neighbors around me, then it's like, okay, I can go into secondary growth now, and secondary growth is sort of like the width, and primary growth is like the length growth. And now we want to split. Now we want this to split off, and Speed3 has a split thing, and Simple Tree Tools also has a split thing, so it's not impossible to do. But it's a bit like more cumbersome to use, because it's not on a per step basis that much, but more like on a like it's harder to control it on a per step basis. Like I just like take my word for that. And now we can say, okay, let's give us a fresh component and attach it. But we kind of want to, and this is where the way this framework is built gives you a lot of control, because I don't want to like control the bifurcation thing on the branches the same way I want to control it on the trunk. So I disable spawn each generation, and as you can see, it's not doing what I intended, because now we are leaving the linear row of nodes territory. But what we do instead is we attach this to this one, just like this. And now we, just for like easier visual representation, we cut both of them, and we take this one and put it here, because now we have like this, the trunk. This is the trunk splitting one, and now we have the init branches main, or init main branches, and main single axis pattern. And now this is like the main extension. Now we can just plug this into the trunk, and we sort of get like a visual representation of what's actually happening, because like this is a branch of the node tree that represents the branches of the trunk, and this is the trunk, these are the branches. And that's pretty damn neat, you know. And the reverse data flow in the system allows for stuff like this, and yeah, that's so cool. Anyway, we want to split. So we go into the trunk splitting, and we already have it at spawn at the end, and now we can start and add more stuff. And now we have like the cluster angle. Don't ask me about the terminology. It's all going to change. But anyway, we also, yeah, we will do init again. And now we have like a split. We can do it with 3. And yeah, you can just separate components like that, and you can like build them step by step if you wanted. Now you get like control over every step. And yeah, that's just phenomenal how much control you can get by doing it like this. If we go into the length and reduce it again, like here, now we sort of get, and now we can really, instead of using control nodes and trying to fiddle around them like like someone who has it not easy in his life, we can go in and just change the values like per step, on a per step basis. And especially for the trunk shaping, this is like invaluable because you don't need as many steps to figure it out. And we can now go and sort of adapt it all a bit more. Yeah, it doesn't have to be pretty for now, but you kind of get the point. And yeah, maybe you want to have like maybe we want to make this an init, and we want to get like an extension, and the extension has just like a single branch, and but has like I always lose track of where the length is. And now we want to have some more like lateral branching, so we just copy our block we had here, but first we do the more splitting that we do want to do at the end. Length, come on, which is again like an init. And now we add the new branch that we have. And I think this is how you intended this to be used, George, right? It just took like a bit of like work and procrastination and time to let it sit to figure this out, but I think I quite got the hang of this now. Right, and now we have like the single axis pattern. Here we have the gather axis, because if you gather these 3 together, there's like a rule that Da Vinci figured out. It's also not like an absolute rule, and science is like, oh, it's not an absolute rule, but yeah, nature. If we would mesh this now, then and that's a bit of a mouthful, the combined area of the circumference of the cross-section of each child of a node is equal to the cross-section area of the parent internode. Okay, or like, yeah, I think you understand what I mean. Like, if I can, you kind of have to envision it because we don't have meshing right now, but like if I would keep it like this, then the diameter of these 3 branches that I would like tuck together would be about the same as the parameter of this segment or of this internode. And these 3 internodes here are like sort of the same thickness as this. And this is why it's called gather axis, because if you gather them together, you get the same as at where they like sourced from. And right, let's get back to the thing. And yeah, we can have so much control over this. Like it's insane. I'm really looking forward to making some plans with this and having the meshing be like really solid. I think this is one of the key areas that needs more love. That's why I won't show it right now, because it's just the last time I used it, it broke like the file I had and stuff like that. And now I'm at a point in the tree where I pretty much don't really want lateral branches. We sort of have this gradient now. Here are like lots of lateral branches. Now we have a bit of forking. Now we have a bit of lateral branches again. And now I just want to like roll it with bifurcation only. And we can go back to the trunk for a second here, and we can set this to relative and add a bit more segments like this. And now we can, just so we have this nice gradient, and to sort of make a point that we can combine things. And if we go in now here, we can start. Yeah, that's gonna be complicated now, but bear with me. I have to sort of figure this out on the fly, because what I want to do now, I want to keep the absolute. I want to keep it absolute, so I can technically spawn like the leaves. So what I want to do is I want to like iteratively split this, but not after each generation. So what I have to do is I have to use a control node. I have to register it, and I have to register it here. And now, yeah, there's some overlap with the breakdown, because I made like a 50-minute breakdown video of the Pine file I made, but the Pine, like the Pine that's not comparable with the amount of information you're getting on this like break up, not not breakdown video. And yeah, what I want to do now is I want to like maybe don't do that for now to not crash, but I want to increase this. Maybe do more like init length. I know I don't even need to, I can keep it short, but set this to absolute. Length absolute. All right, here we go. And I can keep the length like pretty short, something like this. And now I have like 10 generations which have a combined length of this. And if I look at the branching before, I think this is kind of fine. Maybe do like 7 generations. Or 8, because we sort of need to exclude this initialization step, because I don't think we need to initialize anything further down the line now. And now I can go in here and I can I don't know if I can do this actually. This would be something that should be developed further, but I'm very confident that this can be done like much easier than afterwards. But basically what I want to do is I want to, yeah, it is possible, but not very conveniently, and also not very like solidly. Now we're running a bit in a problem, because now I'm like reaching the maximum generations thing, and if I now, oh, okay, it's fine. And if I now set this to 2 or 3, I will pretty much crash Houdini. I'm maybe not crash. Okay, let's wing it. But it will take a while. And I will not do 3. But we're essentially now adding exponentially like the number of segments to the power of 2, I think. I'm not really good at math, but I think this is the case. Yeah, I will cancel this because maybe it will get too much for the system to handle. Maybe we can bring it down to 5, and we kind of see where it's getting at, right? But yeah, instead of crashing like this, I want to tell the control node, like what I want, like George Feike, what I want is a split after n number of steps, or number of branches after n number of steps. Like I want an n number of steps parameter in between those, because right now the spawned 1 out of n is just for like spawning on parent branches, but not like the iterative mode. But yeah, we can try and fake it a little if we like dial this for 1 to 1 right now, and do like 10 again. Now we can sort of, we can take this parameter, paste relative references, use the current generation. And now I want the number of branches, and sadly there's not really a preset for this. And it's kind of hard to set this stuff up. But if we get sort of this like square wave look into it, yeah, it's really hard to control, you know. But what we're getting now is sort of this like branching after every step. And if we like add more generations, like let's do 15, we get like this really, really, really realistic branching pattern, which is awesome. It's absolutely amazing. And if we, the thing is, what makes it so cumbersome, we don't have an easy way of like doing this step length thingy. What I have to do is I have to sort of remove these to do it like this. And yeah, it's not really fun to work with this like that, but it's possible. At least that's something. Yeah. Now we can just like go a bit crazy. Since this is now relative to the whole number of generations, the amount of steps that are between the branching is adapting as well. And this is like, yeah, we need a more like dedicated solution for this, but for demonstration purposes right now, and maybe like teaching you how to get around certain limitations in this tool, this is quite fine. And now we have our bifurcation. Maybe I can do something, I don't know, more like this. I kind of dislike that this is like so like short in succession, but anyway, let's ignore it for now. Doesn't have to be pretty. But yeah, here we have our tree now, and I can go in and like, it's just marvelous, like really. Because now we can go in and we can say, okay, I want to change the gravity for these tweaks, like the later sections, and maybe I can even go further like this. What we want to do now is we want to sort of set the gravity for this one. Let's make it a little bit pretty at least. And we want to add like a bit more interesting, a bit gravity. Like it's really sensitive. And you can now say, okay, I want the gravity. I also want to control it. Like, I think I still have it here, relative reference, current generation, gravitropism. And now you can control it with the curve along the element. And yeah, that's pretty cool. So so that it just has like this progressive decline. Yeah, cool. And now, what is the big advantage why we went to this length of like using it with the absolute and doing all this like fiddly number of branches stuff is that we can now add the final component for the leaves that we use as a sort of guide curve. And I need to be really careful with that. So it just has like one step. And yeah, as you can like, if you can imagine, like you can now have like leaves on this, and yeah, you can like add a step in between, and you can then like, where we can do it just right now, that we add sort of like, okay, let's make this the oops. Let's make this the in-between step. And we can have some more like segments. Yeah, then it inherits the length again, of course. So we set it to absolute. Wow. And do it like a lot shorter. And you can sort of like, if you have good reference, and you can go with like a ruler and measure this stuff, especially with like low hanging branches. But we don't want them to be this high frequent now, these like added branches. We rather want them to spawn like every, I don't know, like 7 segments or something. And all right, yeah. And now we want, because they now have these segments as well, and they sort of have the same like amount, and now we can say, okay, leaves. And you can just hook up the leaves to this one. And you can just hook it up to this one. So you get sort of this nice and tidy. Beautiful. Yeah. And now you have leaves on everything, and you can control the length also. And as you can see, like it's not like instant real time, but given for like how many leaves there are, there's or like leaf curves, it's pretty responsive to work with, and that's pretty fun. So like a leaf has, how long is a leaf? Like 6 centimeters or something. So let's do it like this and set it to absolute. And now we have our leaves. Of course, you have like, yeah, you would have like more bifurcation going on in this one, but I don't want to set up like this cringy solution again. But you get the idea, I think. And now you can go in at any point basically and say, okay, I want to, let's save this for now. You will get this graph and you can poke around it and just pick it apart and follow along. I hope it will be of use. Just as a small tangent, you also have this one, which has like, it's not complete yet. I need to still make the tropism section. But you have like the twisting, like explanations for what these things do, what the solver does, how the flow of information goes, how the relative absolute thing with the length scale is. And you have that all in text so that you don't like need to timestamp and get the information out of the video. All right, back to the thing here. And now you can go back in and say, okay, I want to do the main branches, and here I'm like the trunk. Now you can go in and just tweak these things to your heart's content. He said, and nothing happened. I mean, this works on the init one, but I kind of want to have it work on the other one. I think, is this controlled by anything? Did I use it to demonstrate the control before? Yeah, I did. Okay, so let's remove unregister the control node for now, and now it's not a bug. It's like, more often than not, the problem sits in front of the computer, not inside it. So yeah, another like lesson to be learned. Yeah, and we can tweak it to our heart's content. And we can start with like, we can just copy this like this over. And just start building from this. Or rather, maybe we can just take like this segment here. Because now we're getting into like carrying leaves territory again. So what we do instead is we just take this and attach it to here. And hope we don't crash. Voila! Beautiful, isn't it? Yeah, you get the point. Maybe like don't overdo it like this. Maybe 15 is fine. Yeah, I don't want to get hung up too deep in this. But I think you got the point, right? You have a lot of control, and if you have a bit more time than I do right now, then you can make something really pretty with like tons of control, and you can like all these things I talked about previously, and I will talk about later. Yeah, you end up with like a mix of different things, right? You don't have like one particular phyllotaxy pattern. You don't have one particular way of bifurcation. Maybe you can have like here the like if we take this one, maybe we can add like a little bit of this yeah, this is all right. This is another one like noise. This is always noise, nice noise, and but we can like give it a bit of kickback, like salt in the soup, you know. And I don't know why it's not kicking back. I guess it has something to do with the config. I know why it's not kicking back. It's not kicking back because it's actually not directly attached to the parent. It's attached through this like init thing, and this init thing is set to 3 branches. So I think the kickback will sort of cancel each other out. We kind of need to set it back to like 1 generation or to 1 thing, and this 1 thing should spawn at each generation and have like or at every 5th generation. Or every second for this, but if we do it like here, the twist. All right, here we go. And now we can roll it back. And now it's sort of flat. And if we now go into the init one and give it a bit of kickback, then it should sort of like deflect the parent branch a little bit like this. And now we get this like, here it's nice, you know, like now we get this like kinkiness into the whole, like it's not just a noise, it's really like a deflection, like these things sort of move out the way of each other instead of being on like a straight line. And yeah, maybe this works better if I set it to absolute. And yeah, this is sort of like the gist of the Flora system. There's way more to it, like the meshing, and we have switch nodes, which switch, where you can say, okay, if this and that condition happened, then switch. But this is not implemented right as of now. This is like more advanced, and we kind of needed to focus on getting this basic system going. So yeah, this concludes the video. Thanks a lot for standing by or for like coming along. See you guys in the next one. Goodbye.